Well, this 11-digit number is divisible by exactly 8 of the numbers from 1 to 9. We have to find A and B. Well, the one that jumped out at me when I did this question is 5. So if divisible by 5, then B would have to equal 0 or 5. But B definitely can't equal 5, since then not divisible by any even number, and we know it's divisible by all of them apart from 1. So B will equal 0, but then we'd get 890, and 890 is not actually divisible by 4 or 8. And you only have to check the last 2 digits to be divisible by 4. So in fact, I only need to check 90. 90 not divisible by 4. And therefore, it must be that A, B is not divisible by 5. Okay, it's taken a bit of time, but at least we've ruled that one out. It's not like there's multiple cases. It's simply that 5 is not an option. Now, what I did at this point is okay, here's the thing. If it's divisible by 9, then it's also divisible by 3. So I can almost ignore that one. And if it's divisible by 8, it's going to be divisible by 2 and 4. So I don't need to worry about that. And also, if it's divisible by 8 and 9, it is divisible by 6. So really, I only need to worry about these three. Okay, and you could write that down and argue it. So we need to focus on the conditions for that. So if divisible by 9, and it is, divisible by 9. So the digit sum must have to add up to a multiple of 9. Now, if I add up 1 to 9, there's a quick way to do this. It's to do a half times n plus 1, or half times 9 times 10 in this case, which is 45. Okay, not going to talk any more about that there. That is the formula for triangle numbers. So that is divisible by 9, and therefore we need A plus B to equal 9. Okay, it can't equal 18 because they can't both be 9, because B will have to be even, but we know that it's going to be 9. And you write that down, like why it can't be 18. Okay, so that's going to be useful. 7's a bit trickier. Let's focus on 8. Okay, it's the last 3 digits. So divisible by 8, then the last 3 digits have to be divisible by 8, because 8 goes into 1,000, so most of the number is necessarily divisible by 8, like all of this bit, because it's that many thousand, and then we're left with 8, 9b. So 8, sorry, what am I writing? 8, 9b must be divisible by 8. Well, 888 is clearly divisible by 8. And then 896 must be as well. And then it's going to be beyond that. So we must have B equals 6. And therefore A must equal 3 from this here. So we've got 3 followed by 1, 2, 3, 4, 5, 6, 7, 8, 9. And then right at the end, we've got a 6. And that is our number. Now, the only thing we've not done, and we should do, is just check that it is divisible by 7. This reinforces to us that we've got the answer, and for completeness, we need to show it. So here we go. 7's into 31. We're going to get another 4 here. I'm just working my way through it. 2, that's good. 0, 8, 1, 1, 2, 8. So divisible by 7. And this here is our answer. Right, so that's a fairly quick way of doing this question. I maybe took longer over this bit at the start. We could just immediately see that b can't equal 0 or 5 because 90 and 95 are not divisible by 4. We could go straight to that, to be honest. At some point, you're going to have to do divisibility by 9 to get this condition. Okay, so I always just think it's good to do it right at the start. Um, divisibility by 8 is the crucial thing, really, that completely says that b has to equal 6 for it to work, and then the divisibility rule helped us out. And then just for completeness, check that 7. And then, like I said before, all the rest must go into it, 4, 3, and so on. Just make sure you argue that. Yeah, that's a nice answer, isn't it? Well done.